Homework section 6.2, number 7. We're going to solve for x for the equation sine x plus cosine x equals square root 2. And x, or the answer x, will be between 0 radian and 2 pi radian, or within the first revolution. Recall the answer must be in the radian form. For this problem, we have sine x and cosine x in the expression on the left-hand side. What we're going to do for this case, we are going to multiply or raise both sides to the second power. For problem number 7 of the section 6.2, we have the equation sine x plus cosine x equals square root 2, and x, or the answer x, will be in between 0 radian and 2 pi radians. Recall the answer must be in the radian form. For this case, we are going to raise both sides to the second power. So let's start it with that one to the power 2, both sides. So the right-hand side becomes 2. The left-hand side, we use the perfect square. Make a note, perfect square. If you recall, x plus y quantity squared is x plus y times x plus y, and expanded in the form of the first term squared plus double of the product of the first and the last term plus the last term squared. That means the left-hand side, we will get sine square x plus 2 times sine x times cosine x plus the cosine square x. Use the trigonometric identity for the sine square x plus cosine square x equals 1. So these two terms can be combined and become 1. Now we get the expression on the left-hand side as 1 plus 2 times sine x cosine x equals 2, or 2 sine x cosine x equals 1. And the expression 2 sine x cosine x, 2 sine x cosine x is the trig identity for the sine of double angle. So we just rewrite this as sine of 2x equals 1. That means the angle 2x, that the sine value equals 1, will be the angle 90 degrees, or the angle pi over 2. And make it as a general solution is supposed to be added by 2 pi times k, or the multiple of the revolution. But we're going to find just the x value. So x equals pi over 4 plus pi times k as a general solution. But we are looking for the answer just within the first revolution. What we're going to do next, we just find the x for each k value starting from k equals 0. So x equals pi over 4. And then for k equals 1, just keep adding the k. So if k equals 1, the x equals pi over 4 plus pi times 1. That gives us 5 pi over 4. And the next k equals 2. For k equals 2, x equals pi over 4 plus pi times 2. That is the 9 pi over 4. That is greater than 2 pi. Let's clean this up real quick. So we get pi over 4 plus 2 pi, which is 9 pi over 4. That is greater than 2 pi. So we just ignore the last part. For this case, we are going to check the solution because we are adjusting the original problem by raising to the second power. So let's see if both solutions work for our case. For x equals pi over 4, we check the value, the left-hand side, the sine of pi over 4 plus cosine of pi over 4, which is square root 2 over 2 plus square root 2 over 2 equals square root 2, the same as the right-hand side. Check, so we keep this solution. And then for the next one, we check the same way. So sine of 5 pi over 4 plus cosine of 5 pi over 4. The sine in the second quadrant is positive, so we have square root 2 over 2. The cosine is negative. That means the answer come out to be 0, which is not the same as square root 2. Therefore, we discard the second solution. For our case here, so we have x equals pi over 4 for the answer in the first revolution.